This is medieval Middle Eastern ceramics, and this lecture is an introduction to pottery or ceramics. I like to switch out the terms just to keep everybody on their toes. So this is the earth. Traditionally it's been thought to be made up of things which are animal, vegetable and mineral. I don't know how valid this is nowadays, but humans are animals, we eat vegetables and make things with minerals. I don't know how that works with the mineralogical definition of mineral, which would probably just get everybody confused, but let's not worry about that right now. So according to mineralogists, what is a mineral? A mineral is a single crystalline phase in organic nature. So what does that mean? A single phase means that it may not be broken down mechanically into its components. Mechanically. You can dissolve it, possibly, into its components, but you can't break it down mechanically. For instance, if you take this crystal of halite, sodium chloride, and put it in a salt grinder, because it's salt, what you get is smaller bits of this. You don't get it broken down into its components of sodium and chloride. So that's what it means by it, mechanically. So a crystalline phase means it's not a gaseous state like this, it's not a liquid state like this, and it's not a normal solid state like this. It is a state in which all the atoms are bound into a rigid network extending in 3 dimensions. So that's the crystalline state. And so crystalline phase means it's entirely got this structure within it of one sort or another. There are various sorts. So how does it keep in that structure? So there are various forms of attraction existing between the atoms to form the crystal structure. The most important to mineralogists is ionic bonding. This contains alternating cations and anions. Cations have lost electrons and so are positively charged, and anions have gained electrons and are negatively charged. Electrostatic attraction keeps the atoms together. Why this all works, you'd have to go and look at the archaeology of stuff lectures. So here's an example: sodium chloride, salt. The cation on the left is soda, and the anion is chlorine. So this is very simple and relatively easy to understand. For you to remember this, I come up with this little aid, which is the cat and the onion. Okay? So the cat is on the left. The onion is on the right. So I want you to stare very hard at the screen now. And as these appear, I want you to burn it into your memory. The cat is on the left. The onion is on the right. So the cat, the onion. So inorganic in the environment usually, but not always inorganic. Origins, not organic. And it's natural, not like some synthetic materials which are just very annoying. So that's a mineral. Very important classification of minerals, invented by this chap called Dana. And it's a lot more complicated than we'll be covering here. All sorts of different classifications based on this anionic grouping. But we are concerned about these two at the bottom, silica and the silicates. And we're really only interested in silica, which of course is primarily variants of quartz, because it's a building block of silicates, which you do need to know about. This is one of the building blocks, or the building blocks of quartz, because that's all you get in it, is the silicon tetrahedron. Here's the silica, and it's theoretically shown with the 4 oxygens around it. So it goes to SiO2 rather than SiO4 because you put them all together and it makes less oxygens. So that's what this is made of, but your silicates include the silicon tetrahedron and usually other things as well. But what we're particularly concerned about are silicates known as aluminosilicates, because they will have silicon and aluminium together. See, here's the aluminium octahedron to form the structures. So here you can see this is the aluminium octahedron and here is the silicon tetrahedron. And so these form structures together. And these aluminosilicates include the clay minerals. And this is the structure of the simplest of clay minerals, kaolin. An important thing to note is these things here. I'll get back to that in a minute. This is what those things are. This is called hydroxyl, but it's basically a different kind of water. Not H2O, but just OH. And so here you can see the cat and the onion. In this case, the onion is a group, and the aluminium is the cat, because this is a silicate, a hydrous silicate. This forms these platy structures because of the structure. Quickly go back. The structure of the crystal creates the structure of the mineral, you see, and so it creates this very platy structure. This enables not only water to be in the structure of this crystal, but it means it's attracted to the outside as well. So this makes clays very squishy and plastic and malleable, because the plates like to move against each other when they're wet. So that brings us to what is pottery. Pottery is most often made of clay. Clay is a naturally occurring fine-grained sediment. You can make all sorts of things out of clay, like mud bricks. However, to make pottery, the clay must be made up of clay minerals. Now, there are a lot of things that are called clay naturally, and you might find, oh, look at this, all this clay on the ground. But unless that clay, which is just a fine-grained sediment, has clay minerals in it, you can't make pottery out of it. You can put it in a kiln and fire it, and it just falls apart. It is the clay minerals, the minerals that make the clay pottery, because of the water in the structure, you see. What you just see here. So that when the clay is fired in a kiln, the structure of the minerals is destroyed. And so it has to be stuck like that forever. You can't turn it back into clay. It can, the pottery can break down into clay, but it would take a very long time to break an entire piece of pottery, like beyond human existence, for it to decay completely into clay-like minerals. It happens a little bit, but not enough to turn the whole thing back into clay again. So when it's fired, it's stuck in that shape forever. So here's some pottery. So pottery, unlike metals and glass, pottery cannot be melted down and reused. Once broken, it has to be thrown away or used as something else, but basically you can't turn it into more pottery. Well, you could actually. You could grind it down to very little, teeny little sand-sized particles and add it to other pieces of pottery. This is a type of temper which archaeologists call grog, but that doesn't happen a lot. This is why there is so much pottery. Because unlike metals, it can't corrode. Unlike metals and glass, it can't be melted down and reused. And unlike wood and other organic materials, it can't rot. So whereas in the archaeological record, the overwhelming majority of organic materials have rotted away, the overwhelming majority, like almost all of it, apart from a few bits which have got preserved through very unusual circumstances. All the metal and glass, the overwhelming majority of it is not in the ground somewhere or in a museum somewhere. It's been melted down and reused. Most of those swords have been rebeaten and turned into plowshares and that sort of thing. And the same with the glass. The glass is broken and it's been sold as shards of glass to a glassmaker who turned it into another glass. Recycling is in fact a very old idea and has been used across time. So that's why you can have some sites which are entirely nothing but pottery. It's typically the most common find, and sometimes it could be the only artifact found. This, in fact, is a site on the coast of Yemen where I worked, and the entire surface had been deflated by the wind, so there's no archaeology left here. There's just the pottery. There is nothing to tell you anything about what these people did except the pottery. So that's all that's left. So luckily, pottery is a very plastic medium. Very easy to shape and decorate. And so it always reflects a contemporary taste and cultural ideals. As I said in the lecture or the Zoom meeting, this is part of the idea that started off when the person wanted to make the thing that you're looking at. They would come from a tradition of how to make things. And so that would inform how they made them. They would have spiritual objectives, things to express in that pottery, in that object, I should say. They would have cultural affiliations, tribal associations or something like that, that they would want to express in that object. Basically, there would be a part of them actually in that object. And since pottery is so easy to shape in such a plastic medium, it is very easy to express all those things in the object you're creating, which is one of the reasons I like to have students actually get some experience with clay, so you can really feel what a very plastic medium, and it will do whatever you want as long as you have the skills to use it, which of course ancient peoples did and medieval peoples. But you might not, but they did. So, making pottery. Making pottery starts with a hole in the ground. This is a big clay pit in the Yemen, which I visited in 1988. You might notice that the things with Yemen will have either 1988 or 1989 on it. And in fact, it's either December 1988 or January 1989, which is like the 2 months I was there. This is not me, I took the photograph. So here you can see this major pottery production center has made this very large hole in the ground, digging up the raw materials. Here you can see again from Owen Rye, it's pottery technology. This chap is crushing his raw materials to make it into nice clay. So processing the clay is the first thing you do after, of course, digging it out of the ground. Here you can see some of the components to, see, it's 1989 now. It's probably 1988, I don't know. Actually, I think it was 1989. But it was, here we have 3 components to the clay. You have a fat clay. What is a fat clay? It sounds rather pejorative, but what it means is there's too much clay in the clay, in the paste. And so having too much clay minerals is a problem because it shrinks a lot. And so it'll shrink so much it'll get all cracked and messed up. And it will have difficulty outgassing during the drying and the firing, and so it'll probably blow up. So this is one of the reasons you add a temper. Now in this case, this is the temper, but it's not what you might think of a temper as being a different material. It's a different clay. So you have a clay which has a lot of clay in it, and you have another clay which has not a lot of clay in it. It has more what we will call aplastic inclusions, and we'll get to what those are in a moment. And also they will temper it with another material, camel poo. Manure is a very useful type of temper for making pottery. All plant fiber is moderately useful because it doesn't interfere with what you want the pottery to do. It fires and goes away during the firing process. Droppings like this tend to already be processed into a nice size, and they will also make the clay very plastic because it's kind of squishy and slippery itself. So these three components are what makes the raw material that they then shape into pottery at this particular place. So temper, as I was saying, sometimes called aplastic inclusions, to distinguish themselves, to be distinguished from the plastic inclusions, which is the clay minerals. So they have a number of reasons to be added to the paste. One is they aid the workability during the forming and construction of the pottery, to actually make it into a jug or a bowl or whatever. They reduce the shrinkage during the drying. Before you fire it, and you make the pot and you put it aside and let it dry. And so when it dries, if there's a lot of plastic material in it, it will shrink a lot, and that might be problematic. It'll then provide desirable properties during the actual firing. If you have the wrong materials in it, it could blow it up or cause other problems. And it will provide desirable properties to the finished vessel. There might be something that you want the finished vessel to do that the inclusions you've added, the tempering, will aid. So you will have, so in this case, you can see it has these little white inclusions here. And this is actually the same pot. And this is a cut through the vessel, where you can see this handle has been added to this vessel, and this has more of these little white inclusions than the main body, and that's because of the shrinkage. They would have made this vessel and let it dry, and because they're having sort of mass production sequence thing going on, and then sometime later they would come and apply, when this is dried somewhat, apply the handles. And if this had the same amount of aplastic inclusions, these would shrink so much they would fall off. You can see that they have shrunk a bit because there's a bit of a crack here, but not so much that it's fallen off. So that's why they added so much aplastic tempering to this, to reduce the shrinkage. And here you can see in this thin section all the inclusions, aplastic inclusions within this clay matrix. So here we have another source I often use, Hans Wolf's Traditional Crafts of Persia, 1966. And here you can see this chap is processing this material further by grinding it. This is for very fine pottery, which of course is what we'll be looking at quite a lot. And so now this chap is kneading the pottery, because it might have been dry and crushed and stored, but now it needs to be turned into something you can work and actually make pottery with it. So there are a number of types of construction or forming. The simplest you would have used back when you're a child playing with plasticine, and that's called modeling. And so you would make your dinosaur by squishing your piece of plasticine until it was the desired shape, just as this was made the Venus of Doni Vistonice a very, very long time ago, just by pushing the plastic material until it was in the right shape. So the next idea of that is actually pinching it into a pot, often called a pinch pot for the obvious reason. And this will create small vessels, no bigger than you get your hand in, shallow bowls and shallow pots like this, which coincidentally is exactly what some of the earliest pottery made in the Middle East looked like. You might find impressions on them, and you will, by looking at the inclusions, sometimes there are no visible inclusions and sometimes there are, but if this has been pinched, then the inclusions will be completely random, looking at the outside of the vessel like this. If you look at a broken section or a cut section, they'll be perfectly aligned with the outside of the vessel. So you will know that this is probably from a pinch pot. You might also then have the vessel drawn just by grabbing the edge of the pinch pot and pulling it up. So this chap, and we're going to see this whole pot being made from Owen Rye's book on pottery technology. He has got this slab of clay and he's put it on this turntable. So this is not a wheel as in thrown from a wheel. This is just a slow wheel, not the fast wheel. And this turntable, he'll just turn it around just to help him work on the clay. And you can see what he's made here is a round slab. So this is a slab. So in a way this is like slab construction, but he's actually going to do more with this, but it's a good time to talk about slab construction. And so with slab construction you can make whole vessels with these slabs. And rather like pinch pots, the inclusions will look randomly oriented on the outside of the vessel, so if you're looking at it here, but the section there will be parallel. What distinguishes this from a pinch pot is that it's big. This is much bigger than a pinch pot could be. You can't pinch that much clay, it would be ridiculous. And also you'll find that where the slabs go together are points of weakness. So if you can't actually see the traces of the joins, you can see where they break like this. So you can see these are rims of vessels. These are all made in the Yemen in the 9th century actually, so we'll be looking at these. But they have broken. See, the break here is parallel to the rim. All of these breaks are parallel to the rim. And so this shows that this was actually a slab, and these vessels were constructed using slab construction. Sometimes you might have the shape of the vessel is indicative of slab construction. And you couldn't throw this on a wheel, for instance. This is obviously a slab or several slabs stuck together to make this squarish pot thing. In this case, the slabs were made using a mold, but they're slabs nonetheless. So he's got his slab here, and he's adding to it with these sausage-shaped coils of clay. So he's got the squishy sausage of clay, and he's adding it and squishing it together with the rest of it to build it up into the vessel. So you can make the whole vessel like that if you like. You're not likely to see evidence of that like this. That would be weird. But it might show breakage patterns like that. Breaks tend to be very random. You will not have any structure in it whatsoever, like in a sherd. The inclusions will be very randomly oriented. in the section, but the profile, looking at the side of the vessel like this, like here, they will be oriented because they've all been coiled in this direction, and so they've been oriented. But in this direction, they're made up of coils where the orientation would have all been going around in little circles. In fact, sometimes you can see their little circles of inclusions within it. So that will give you some evidence that coil construction was involved. Here we have this young man is making these sausages. This is pictures I took in Iran in 1996, August 1996. This is not a out of scale mixer for the kitchen. This is actually a mixer for clay. You can see this is a massive thing that they would have mixed all their raw materials together to make this nice soft squishy clay, which you can see he's turning into coils, and you can see it turns into a much healthier looking individual than the youth of today who are busy looking at their cell phones. And here's what's probably his dad. He's constructed this thing. I just call it a thing at the moment. And he's squishing those coils together so that it forms this nice smooth surface. This is actually a tannour, an oven, and they would cook bread in this. And so that's all coil construction. What this young chap here is doing, I shall come back to in a moment. But when I was here, I actually didn't know he was there, but I could hear him. There was this noise of like a stone being rubbed against something. And that indeed what was going on. And then I went towards the back, and then suddenly he popped out. Quite alarming, actually. So, back to Pakistan in 1981. And here you can see this chap is making this pot. So remember there's a big round slab at the bottom, and he's used coils to construct the top part of the pot. Now he's using a very important aspect of this, a tool. So tools are very important. Looking at how tools change the clay is something I'd like you to try when we're making pottery at the ROM. Use some of the tools to see how they affect the clay. And you can see that actually in the archaeological record. So the next thing he's doing is called decorative forming. He's applying decoration. It looks like it's rouletted or something, or it might just be very well organized and doing it orderly. He's creating this decoration in the soft clay. So this is like forming, but it's just decorative. So there's all sorts of decorative formings, and I'm afraid we're going to have to cover them. So, but he hasn't finished making his pot. He's now going to round the bottom with a paddle. In his other hand here, you can see his other arm going up inside. He will have probably a large round rock in his hand. That's the anvil. This is the paddle and anvil technique. And he's whacking this bottom in order to stretch it out and make it form a dome, a rounded dome. So, paddle and anvil technique will leave evidence of the anvil on the inside and the paddle on the outside. Of course, they'd be wanting to smooth it so you can't see that, but you have to look carefully and you might be able to see it. Sometimes they will actually use a paddle with a design on it to create the design, and it makes it very obvious how it's made. The inclusions tend to get whacked about a bit, and that whacking will often create breaks that go along the surface. It's very parallel in section, and you might also in section see remains of paddling and anviling on the surface. This is some pottery from the Yemen again, but they're actually imports from India, and in this they were using a paddle that had a pattern on it to create this interesting design. So that's sort of like a pattern created by the construction. So there we have his finished bottom, and he's smoothing it and trying to remove all the signs so future archaeologists can't work out how he made the pot. This is what potters have always tried to do, to try to make it as difficult for archaeologists to work out the construction technique as much as possible. So, a couple of other techniques that chap in Pakistan didn't use. Moulding. There's a number of lines of evidence to show you when people were using a mould to make pottery. One is the shape of it. This would work really well with mould. This would not. Because you couldn't get that in a mould. Maybe a two-piece mould, but it wouldn't work that well. Here you can see this has been moulded. This hasn't been moulded, but it's been joined. And one thing is, if all this vessel has been made in a mould and it's been joined to this other bit, there's going to be a weakness here where the join is, and you will see this weakness, and you will say, this has been moulded. I can see where the two parts were put together. How they did it from up here, they would have to either throw it or put coils on it or something like that. And you might see structures like this where the two halves were like stuck together. Another thing you might see is evidence of a parting medium. Quite often the mold will have dust put on it so the clay doesn't stick to it and is released from it more easily. And this shows you the sort of thing you might see in the orientation of the inclusions. It'll be moderately flattened on the outside, but towards the inside they'll be quite random. Looking at this is actually the mold, or a mold. It's not the mold for this, but this is more evidence of determining that this has been molded. To start with, this is actually not a shape you can throw, so that would suggest it's not been a thrown vessel. It's not round, but mostly it's the decoration, and you can see it's quite detailed. And it's made of these lines. Now, what you need to do is look at that and think, if this was a vessel that someone, say, made a pinch pot and then made this design in the outside of the vessel, this would be a lot of work, creating this raised line. However, if this was molded like this raised line is just a simple incision into the clay. Very quick and very easy. So that would mean this is either an incredibly large amount of work or it's molded. And in fact, it's molded. So always look for like raised lines like this, which would indicate it's actually a simple incised line in the mold, which comes as a raised line in the finished object. And this chap is here. I actually can't remember how he made his pots. They could be coil, they could be slab. But unfortunately, the thing that was most interesting is he ran around the pot, which unfortunately I didn't have a recording device at the time, so it actually looked like it was thrown on a wheel, superficially, because he was like running around at high speed with his hand, making it all even. So, wheel thrown construction. So what the wheel does is, by centrifugal force, it throws the clay away from the center. So if you ever have a go at throwing pottery, you'll find that the throwing is done by the wheel, and it will throw the clay around the room if you're not careful. We won't be doing that in the studio downstairs. It'll all be hand construction. But that centrifugal force will throw the clay up, controlled by the hand of the potter. And here you can see the traces of that hand guiding the clay up. So this whorl shape at the bottom is very distinctive and characteristic of a wheel thrown vessel. So here you can see actually in the base of a 9th century vessel from the Yemen. Also these very fine lines. You can get lines on the outside of a vessel if it's been smoothed with a hand, but to have them so very, very, very regular is not likely. This is evidence of this vessel being thrown on a wheel. Another line of evidence is a string cut base. This is a string cut base, and so you can see this was once on another lump of clay. So the vessel was thrown on a lump of clay which was on the wheel, and then someone removed it from the wheel by putting a piece of string and pulling the piece of string through the base to leave this trace. And this is very distinctive and is evidence of it being thrown on the wheel. Usually they will then flatten it out, but they didn't bother in this case for some reason. So this is a wheel. This is more photographs by me. This is the wheel. This is actually a big steel wheel with the wooden bit on top. And so what happens, he's got, see, one foot is resting on a bar here, and the other one is kicking the wheel. This is a kick wheel. And so he's kicking the wheel and it's going round. And so what the weight of the wheel is what helps it keep going around in circles. So this shaft goes up and in front of him where the wheel is. Okay? The pottery goes on. So how you can see, he's making a bowl. This is a very small bowl. Well, not a very small bowl, but it's much smaller than the lump of clay he has. He has this massive lump of clay. And so this is what is known as throwing from the hump. This is a hump of clay. Hump like a camel's hump. And so he'll throw this vessel, and you can see he's now making sure it's about the right size. And then he will use a piece of string or a wire or something to cut it off and put it aside. And then he's going to throw another vessel from the same lump of clay. Because one of the biggest time sinks is actually getting this piece of clay centered on the wheel and getting it all working nicely. So it's better to have this large lump of clay and then slowly make the bowls from it. So other lines of evidence, those very fine lines, incisions that are made as the wheel is going around. Here you can see designs incised on the outside on a moving wheel, far too regular than could be used on not a wheel. The way that the vessel gets progressively thinner as it goes up. Here is an idea. These are the inclusions again, and because it's thrown up as it's been going around, all the inclusions are angled like this in the side of the vessel, and they're parallel to the sides of the vessel. Another construction technique, which in fact related to throwing because it's also used on the wheel, is turning. And this is what you do after you've made the vessel. You've let it dry to a certain extent because you don't want it too squishy, and then you put it back on the wheel, and you have like a lump of clay or something here. You see the lump of clay here, and you put the vessel on because that lump of clay at the base before might not be very nicely done. And so what's happening is he's turning this vessel down now to make a nice foot ring. You can see here this has been cut down to make a nice foot ring, and this make a nice rounded bottom instead of like the flat one it would have had before. So on this then you'll have the very fine lines of the hand working on the soft clay, but here on the dry clay the tool is dragging grains along, and so this will have a very different look. And of course you'll be looking at all of this in person in the lab. You will also find differences in thickness that show that this has been cut. Maybe thicker or thinner. It'd be very different from, say, if it was just this rounded bottom and someone had applied a ring to it. Another thing you might find is that when they put the vessel back onto the wheel, it wasn't centered quite perfectly, and so something is not quite right. Maybe the ring is thicker on one side than the other or something like that. So another construction technique, and I think the last one thankfully, is shaving. So shaving is basically you use a tool like turning, but you don't have it on the wheel. And this vessel actually I think may be turned rather than shaved, but the main thing is you can see up here the soft impression of a hand on wet clay, and down here the angular impression of a tool on not quite a soft clay. And so it's been dragging grains, and you have these angular cuts. So whether this is completely random like this or very regular from being turned, there is a clear difference between the bottom and the top. So then you will possibly join components even made different places by using bits of soft slip clay. A slip is any type of clay in suspension in water. And so slips are actually a type of decorative forming as well, which we shall come to. So burnishing is basically you rub the outside of the vessel with something like a shiny little stone or something, and that'll orient all the clay on the surface parallel to the surface, and it'll make it nice and shiny. And that's what this young man was doing at the back here in the tannoy when he popped out. And I said, "Oh my God, what are you doing?" And he's got a little stone in his hand. He's spending all his time rubbing the inside of this vessel, because this is where they would slap bread up against it during the cooking, and they want it to come off of the tannoy again. Here you can see this chap is doing the same thing with a very different tool. He's got some sort of metal tool, and he's actually got it in the pot too. So incision is another form of decorative forming. Here you can see all these lines have been incised into the pottery. It's interesting to note that this slightly earlier vessel, this was done when the pottery was wet, and so you can see it's sort of smooshed up on the edges, whereas this one slightly later was done when the pottery was dry, and it sort of like chips off in places. So although this is actually related to that, by the time they were doing this, they were leaving more time between the forming of the vessel and the decorating it. And there's an excision, which means you basically cut bits out. Molding is a form of decorative molding as well as construction. Applique means you apply bits of clay to it, like on here, there's a close-up. You can see they've added a nose and eyes and things. Impressed, here you can see someone has impressed something into the surface here to create these little patterns. This is here they've impressed a fork or something into the outside. It's probably a fork. It'll be a lot of work to do these as little dots, little sticks. Sprigging, I keep trying to find an ancient Middle Eastern thing. I think I did find one once actually, where you have this shape which you then apply to the outside. So it's like a molded thing which you push into the side. So you're adding clay as well as shaping it at the same time. That's sprigging. Punctate means there's a hole actually going all the way through the vessel. Modelling, again, is a decorative forming technique. See, this has been modelled on this vessel. Repoussé basically means it's been pushed out from the inside. And combing. So here there's definitely a comb, and they've combed the outside. So it's a form of incision, but you're using a comb instead of just one of them at a time. And rouletting, and so somehow you've got something round and you've rolled it around on the outside to make a design. So you have all these types of forming. But this is decorative forming, not construction. And slip is another important thing. And so this is slip. It's clay in suspension, and you can have a full slip in which the entire vessel is covered with slip. You can have a partial slip where you just have a bit of it, and this lady's painting some slip onto the vessel. This guy has poured some slip onto the inside, and you can see only the inside has this nice dark slip. You can have slip paint. This has been painted with slip. You can have slip incision. This has been covered with a complete slip, the white bit, and then has had lines and size through it, so you can see the red clay underneath the white slip. You can have slip excise, so here you have the white slip over the red vessel, and it's been excised to reveal the pattern. We'll be seeing all of these. You can have a false slip. Here you can see the red clay here, and the surface is paler. And so some people think, oh, this is like a slip. But what actually is this efflorescence of salts on the surface. So this is called a false slip. Now we come to glazes. We're in a bit of a hurry. So this is a glaze. So this is a glass on the outside of a piece of pottery. This is a slip, and this is the clay body. So glazes are a glass. It's an anthropogenic glass, predominantly made of silica, and the melting temperature of silica is between about 610 and 1713 degrees centigrade. And most kilns, especially the ones we have in the Middle East, go between about 800 and 1100 degrees centigrade. So that means you need a flux. So a flux is another element which you've added to the silica that enables it to melt at a lower temperature. Much as very Canadian content here, you add salt to ice on your sidewalk to make it melt at a lower temperature. Because the crystalline form of water is ice. But when you add salt to the water, it then has a lower solidification temperature. It has to be really, really cold before salt water will freeze. And so we don't get that here. And so it acts as a flux to make the ice melt. So a flux added to silica will also make it melt. So one of these, very common one in the Middle East, is lead. So in this, there's actually up to 60% of lead, so it's more lead than silica. This will come from lead ores such as the lead sulfide galena. Appeared in the 1st century BC and seemed to be immediately everywhere. Used all the way across the Silk Road. So the idea must have either started at one end or the other and quickly came to the other end. So this is actually from the Roman end and has a lead glaze, a high lead glaze. So don't lick it. And we also have alkali glazes. Alkali glazes contain 20 to 30% alkali elements such as soda and potash. And these have a plant ash source. You have these halophytic plants. And you also have natron, sodium carbonate, from Egypt. So you only get this in Egypt, though. So this was first developed in Mesopotamia, originally used on this glazed composition, which is like crushed quartz. And after about 1500 we see it's found on clay. And we have a lot of alkali glazes in the Middle East. So, hopefully this is finally, is paint. Painting, you see this chap is painting this vessel. So there are a number of types of paint. This is a pigment paint, sometimes also called underglaze paint because it's under a glaze. This is chromium actually, and this is just chromium oxide painted on the outside of this vessel, and then it's covered with a glaze. Enamel paint is again a glaze-related paint where you've had a glazed vessel, in this case an opaque white glaze, and then they've painted on it with these glassy paints and then fired it again. So the paints have fused to the surface. And we'll be talking more about that. Inglaze is another technique. In this case, what they've done is they've made the vessel and they've glazed the vessel. Okay, so it's got a glaze on it. So a glaze, when it's applied, is glass which has been crushed into a very fine powder, which can then be put in a fluid medium like water and applied to the outside of the vessel, and so it's just slooshed over, and so that the glassy particles are left behind. So for the one before, what happens is then the vessel is fired, and so you have a glazed vessel. and then the enamel paints are put on. But for the inglaze, the paint is applied to a vessel which has not been fired. And so when it's fired, the paint sinks into this sort of smooshy. It's not as precise and defined as this has actually been mended here. Never mind that bit. And so it goes sort of squidgy and bleeds into the glaze. And you have slip paints. So this vessel, and I showed you another slip paint earlier on, talking about slips. This is got black slip painted onto the surface. This is then had a lead glaze. You have luster paint. Luster paint's a whole thing. It's a metallic paint, and I'll be talking a lot more about this later on. So luster paint's another type of paint. And that's it. So that's not the last thing. So here we are, fire clay ceramic type. So yes, because we've made the pottery now, we painted the pottery, we need to fire the pottery. There are three main types of fire clay ceramic. There's earthenware. This is what Middle Eastern pottery is like. It's all fired between about 700 and 1200 degrees centigrade. Stoneware is a higher temperature, about 1200, 1300 degrees centigrade. This we do get very rarely in the Middle East. When it happens, it's noteworthy, and I will tell you. Assume everything is earthenware temperature, unless I tell you otherwise. This is from China. So there they have high-fired ceramics, because they have these dragon kilns, which can get to high temperatures. And so they make stoneware, and they make porcelain, which is very highly fired, and this was never made in the Middle East in the medieval period, although I think they were making it in the 19th century. So another important thing about kilns is they have this thing called fugacity. And you have reducing and oxidizing. So oxidizing means there is oxygen in the kiln, and that'll have an effect on the color of the pottery. In this, just a burnished vessel. Where it's oxidized, it's red. Where it's reduced, it's black. How this vessel has two, I'll leave you to conjecture. Maybe we'll talk about it later. So we get to the kilns. So this is actually not a kiln. It's just a hole in the ground, or not actually much of a hole, and they fire the pottery in it. So that's an open firing. This is more of a hole in the ground. So this is a pit firing, and here you can see this looks like that vessel that chap was making, doesn't it? And then we come to simple kilns, beehive kilns, in which you have the kiln to contain the pottery, and you put a fire underneath it. And so this heats up the kiln and fires the pottery. And then you have the most advanced form of kiln, which they use to this day, which is the updraft kiln, and in which they have the fire over here somewhere, and it's just the heat goes in. So you don't actually have burning of the pottery, which you would have in a beehive kiln. And so this is high quality ceramics we're dealing with here. And this is just Middle Eastern kilns. I'll show you a dragon kiln later. So this is inside a kiln. Interesting look. This is Shareza near Isfahan, published by Hans Wolf in 1966. And this is my photograph in 1996. And it's funny how in 1966 seems so long ago. But again, this is another 30 years later almost, isn't it? It's horrifying. Anyway, so in 1996 I was there at Shareza near Isfahan. And this is a kiln after the firing. See, there's nothing in it except these. This is called kiln furniture. And I'll talk more about kiln furniture later on. But basically it's pieces of pottery which are used in the kiln as furniture, I guess. You can see these are actually these little divots of clay which had been fired before, and they're just stuck in the side. You see here's the holes where more can be put. And here it's all got ready for the firing. And so here we have these rods of clay which go into the side, and here they have these flat sheets of clay, which they were going to put the pottery on. And here's the pottery. And you can see it's painted. So in this case, the glaze is just a powder of glass on the surface, and the glaze and the paint is just this gray color on the surface. And so then it's fired. And here you can see there's this chap on top of the kiln looking down the hole. Interesting to see they have pottery here. This is drying above the kiln. And so, because you want to get as much water out of it as possible, out of the pottery, before you fire it, because otherwise all sorts of bad things happen. So you dry it for some time. Here it's being super dried by putting it on top of the kiln. And then when it's really, really dry, they put it in the kiln. So what this chap is doing, you can see, look, he's very concentrating, and you can see he's judging. He's judging how hot this is. And so you can see what sort of temperature this is by comparing it to this. So this is sort of orangey, almost yellow, but more orangey than yellow. So it's around here somewhere. So this is the right temperature for a piece of pottery, for the pottery fired as high as you're likely to get this sort of kiln. That's a good high temperature for this kiln. And he doesn't need a thermocouple, which is a thing that will tell him the temperature down there. He is just a very skilled chap that knows what he's doing, and he can work out that's the right temperature. And here you go. This is the fired pottery, and you can see this is what the glaze looks like after it's been fired. So this is a video. This is definitely the end of the lecture now. And here, this video is of a pottery manufacturer I saw in Syria. And these are clay settling pans, which are very important. Because the thing about clay is if you squish a lot of clay in here, the non-clay minerals will settle to the bottom before the clay minerals. Clay minerals like to take a long time to settle. And so right at the top will be the clay-rich material. So that's what you will make the slip with, and will be an important component of the clay. Here you can see they have the clay, and the sieves were for, taking out lumps that might have been in the clay when it dried. And so here, these chaps, this is actually on a Friday, because, I'm working in Aleppo on an excavation, and Friday is our day off, just as everybody's day off. And whereas for a lot of other industries I went to, Friday was their day off. But these chaps were making a lot of money out of making pottery. They were making art pottery for the German market by this time. And so they were making so much money, they're in their equivalent of the Sunday best, because Friday is the holy day, and the day you go to the mosque. If you only go once a week, that's the day you go. And so they're actually wearing very nice clothes that, unfortunately, they're going to get clay on, but that was very nice of them. But you can see he's kicking the wheel. This is a kick wheel. And that is making the wheel go round. I'm pointing at it with my finger, but you can't see it. Okay. Yeah, if I do this, it stops. I can take my hand off the mouse now. So you can see how the power of the wheel going round is what actually makes the clay go up to the vessel. And the man is just gently but firmly guiding the clay to take on the shape of the vessel he wishes it to do. But he's just guiding the clay using the energy of the wheel. So this is a very skilled potter who does this all week, just usually not on Friday. And so you can see he's pushing up some more from the inside, making the pot larger. What they were actually selling to the German art market is what they were doing, or they were making these large pots, something like this, then cutting a hole in the side and creating landscapes inside with clay, with little houses and trees. And apparently the Germans loved them, and so they make a lot of money selling them to Germans. They were shipped off to the Rhineland or something, and made a lot of money. And here you go, see, string cut vase. And so there is your pot. Is he going to do another one? Okay, he's going to do another one. Okay, so he's going to do another one, which you can watch because it's very therapeutic and very nice to just watch the clay. See how plastic the medium is. But just with a touch, it creates the shape that you wish it to. Okay, he's fiddling. I don't know what he's doing there. Maybe there's something unpleasant in there. Be very problematic if something unpleasant got its way into the clay. If it's going against your hand at such speed, you could cut your hand or something if it was sharp. So it's possible they're complaining about these bloody people coming and disturbing their Friday day off. But my Arabic is far from sufficient to understand if that's what they're saying. But would be quite justified. But we weren't demanding. We just came by and asked if we could look around. And they came out and made pottery for us. It's not like we were saying, "Hello, we demand that you make pottery for us." We just wanted to look. But they were so nice that they came and made pottery. A bit more water there to make it more plastic. So as I said, we won't be doing in the studio downstairs making pottery on a wheel, because unless any of you have experience of it, this would turn into a complete disaster. And the entire museum will be covered with clay, and you will be covered with clay, and probably people would complain, and then we won't be able to do it anymore. Whereas using the other techniques I've showed you, slab construction, coil construction, you should be able to make a vessel that could hold paper clips or something, I don't know, that will be of some use. Certainly of some use if you give it to a relative for Christmas or something. So here, see how easy it is to shape this? And then it dries, and then it's fired, and then it's stuck in that shape forever. Look at that. And there's the finished vessels. You see the grapes? There's a whole bunch of other pots outside. And this is the kiln. That's the kiln there. And there you can see it's actually a beehive kiln, not advanced like the Iranian one I looked at, and the fire is down there. This is the lid of the kiln. And this is the fuel. So it's just any old thing, and there's like nutshells and pistachio shells, and these are the pots. See, very decorative, which they sell to the Germans. Well, I don't seem to have a picture. That's the kiln. There's the kiln. Don't seem to have a picture of those ones with the hole in the outside where they build little scenes. So, that's it. And that concludes the lecture for today. Thank you.